Good morning students. Today we will discuss class 9th chapter 2 is matter around us pure part 2. In our part 1 we have discussed about the chemical properties of matter. On the basis of the chemical properties we have divided the matter into two categories, pure substances and mixture, and we have completed the pure substance in our first video, and today we will discuss about the mixtures, homogeneous and heterogeneous mixtures, further homogeneous, true solution, colloidal and suspension. So let us start. Pure substances we have discussed in our first video that are made up of single kind of substances are known as pure substances, and the mixture which are made up of more than one kind of substances are known as mixtures. Now in this container you can see this mixture is made up of more than one kind of substances. Types of mixtures. Mixtures are of two types, homogeneous mixtures and heterogeneous mixtures. The word homo means same and the word hetero means different. Homogeneous, homo means same. The mixtures which have same composition throughout the mixture is known as homogeneous mixture, and heterogeneous which have different composition throughout the mixture are known as heterogeneous mixtures. Homogeneous mixtures. Homogeneous mixture has uniform composition and properties throughout its mass is called homogeneous mixtures. Homogeneous mixtures are those solutions which have uniform composition throughout the solution. If we take water and add sugar in it and dissolve the solution, after some time what we will observe, we are not able to tell that solution contains sugar. It look like transparent solution, and that type of mixtures are known as homogeneous mixtures. For example, salt and water solution, sugar in water. So all these are the examples of homogeneous mixture. All the liquids, all the solutions are the examples of homogeneous mixtures. Now second is heterogeneous mixtures. Heterogeneous mixtures which have different composition and properties in different parts of their mass is called heterogeneous mixture. For example, you can observe in this container, we dissolve sand in this glass, then what we will observe, two layers are formed in this glass. So this kind of mixtures in which we can observe the contents of that mixtures are known as heterogeneous mixture. For example, suspension and colloid. Suspension, sand mixed with salt, sugar in oil, and colloids, milk in water. We will discuss in detail in further. So these are the kind of mixtures, homogeneous and heterogeneous mixtures. Now first we will discuss about the homogeneous mixtures which contain the solutions. What are solutions? Solutions are the homogeneous mixtures. Solutions are the homogeneous mixtures of two or more substances. And every solution has two parts, solute and solvent. And what are solute and solvent? Solute is the part which we are going to dissolve, and the solvent is a substance in which we are going to dissolve that solute. Means the solvent which we take in larger quantity in solution and solute which we take in lesser quantity. For example, solution of sugar and water. In this mixture, what we will take in larger quantity? Water. So water is a solvent, and we took smaller quantity, smaller amount in sugar. So sugar is a solute. Before starting in detail about the solution, we should know about some terms about the solutions. Soluble. Soluble means the substance that dissolve in a solute. If it completely dissolve, it means that substance is soluble. Now, second is miscible. If the two substances are soluble in the solution are known as miscible. A substance that doesn't dissolve in a solvent is insoluble. For example, if we dissolve a pebble or a stone in a water, it will not dissolve. So this kind of solutions are known as insoluble. It means the stone is insoluble. Two liquids that can be mixed but separate shortly after are immiscible. Two liquids that can be mixed but separate shortly after immiscible. For example, if we mix oil plus water, then what we will observe? We form a oil layer over the water. That kind of solution are known as immiscible solutions. Next, types of solutions. Types of solutions. An unsaturated solution. We have three kind of solutions. First is unsaturated, second saturated, and third is supersaturated solutions. What are these? Unsaturated solution is a solution in which more solute can be dissolved at a given temperature. For example, we are adding more and more sugar and dissolving it in water. So that kind of solutions are known as unsaturated solutions. Saturated solution. When we dissolve, we take 10 ml of water, 10 ml of water, and we dissolve a sugar in larger quantity. Then what will happen? At a certain point, the sugar stop dissolving in this solution. That kind of solutions are known as saturated solution. Third is supersaturated solution. Supersaturated solutions that contain more solute than would dissolve in saturated solution at a given temperature. If we heat saturated solution, keep adding the sugar in it, then what will happen? It will dissolve but form crystal of that solute. That kind of solution are known as supersaturated solutions. Now, here we can observe unsaturated solution, saturated solution, and supersaturated solution. Unsaturated solution means more solute can be dissolved. Saturated solution means no more solute can be dissolved. And supersaturated solution means become unstable and crystal form. For example, when we make chasni in our homes, we keep adding sugar and by heating at certain temperature, when it reach, it form crystals of sugars. That kind of solutions are known as supersaturated solutions. Now next is concentration of solution. Concentration of a solution depends on the amount of solute dissolved in that mixture. For example, first of all, we will observe the definition of the solution. It refers the amount of solute dissolved in fixed amount of solvent. A solution containing small amount of solute is known as dilute solution, and a solution containing large amount of solute is known as concentrated solution. For example, if we add less amount of sugar in more quantity of water, means dilute solution. If we add more quantity of sugar in less quantity of water, that is concentrated solution. In concentrated solution, the amount of solute is more, and the dilute solution, the amount of solute is less. Suspension. Suspension is a heterogeneous mixtures, kind of heterogeneous mixture. Suspension, when solid does not dissolve in liquid, suspension is formed. If we make a mixture and the solute is not going to dissolve properly in that solution, is known as suspension. Suspension is a mixture in which insoluble particles are suspended in liquid or gas. That kind of mixtures are known as suspension. For example, sand in water. We can observe this separate layers in the solution. Sand as well as in water, we form two or more layers. And for example, if we dissolve oil in water, then we form two layers there. Both are immiscible in it. So that kind of solutions, that kind of mixtures are known as suspensions. For examples of suspension, hazy environment, when we form so many suspended particles in the air. Second is medicine, thick medicines. Observe thick medicine, we can observe the different layers of solutions. Chalk and dust powder, if we dissolve chalk powder in water, that kind of solution is also suspension solution. Calamine lotion that we use as a cosmetics, that is also a suspension mixture. So suspension mixture containing insoluble solid particles suspended in a liquid. In a liquid, if we dissolve solid particles, if we form solid particles which are undissolved in the solution, are known as suspension. Suspension is formed, solute particle remain as large visible. We are able to observe the particles in the solution. The particles of the solution are visible to us. These are the suspension. Now next is colloid. Colloids are also heterogeneous mixtures and colloids of a solvent and suspended particles. The size of the particles of the colloid is intermediate between the solutions and the suspensions. Particles are too small to see but are larger than molecules. Due to their small size, they do not settle out of the solutions. They remain suspended in the solution. There are several types of colloidal: aerosol, foam, emulsion, solid, solid emulsion and solid. And how they form? If we mix gas with liquid or solid, then form aerosol. And these are very, very important. Every time one question comes from this portion. So always remember that aerosol is a mixture of gas plus liquid. For example, fog and smoke. Second is foam. Foam is a mixture of liquid plus gas. For example, whipped cream. This is very, very important part. Emulsion is a mixture of liquid plus liquid. For example, milk. So what kind of milk? Milk is a colloidal and emulsion. Sol is a mixture of liquid plus solid. Paints are mainly what kind of mixtures? Sol. Colloids mixtures, and colloids में sol. Solid form, solid plus gas. Marshmallow, solid emulsion, solid plus liquid. Butter, solid plus solid. Pearl, opal. So these are the examples of colloids, and these are very, very important. One question always come from this portion. So please keep remember this portion. And what are colloids and what is the difference between solution, suspension and colloid? Colloids has two phase, disperse phase and dispersion medium. It is similar as the part of the solution. In solution we have discussed about the two parts of the solution, solute and solvent. Similarly, the colloids have two phases, disperse phase and dispersion medium. Dispersion phase act as solute and dispersion medium act as solvent. Disperse phase in a colloid, suspended particle are called disperse phase, which we are going to mix are called disperse phase. And dispersion medium, the solvent in which suspended particle are suspended, is called dispersion medium, which is we have taken in larger quantity, same as solvent. In colloids we use the term dispersion medium, and in solution we use the term solvent. Similarly, in solution we use the term solute, and in colloids we use the term dispersed phase. Types of colloid we have done in our last pic. Here aerosol, smoke, foam, emulsion, sol, solid, marshmallow, solid, emulsion, solid plus liquid, solid, sol. So we have to remember these, what is the mixture of solid, sol. So we have to remember solid plus solid and we form pearl. Next is Tyndall effect. Very, very important. 90% it comes in exams every time. Tyndall effect is very, very important. You have to remember this. Tyndall effect. Tyndall effect, when a beam of light passes through a colloidal solution, the colloidal particles scatter the beam of light and the path of the light become visible in the solution. This effect is known as Tyndall effect. Tyndall effect can be seen when light enters a room through a small hole due to scattering of light by the dust and smoke particle. Tyndall effect can be seen in a dense forest due to scattering of light by water droplets in the mist. Okay, we can observe the size of the particle. According to the size of the particle of the solution is very, very small. So they are not able to scatter the light. When light fall on the solution particle, they don't reflect light, but when the light falls on the colloidal solution particles, they reflect the light, and due to this phenomena the path of the light become visible, and the path of the light which is visible to us is known as Tyndall effect. You can observe in the dense forest this kind of phenomena, and we can observe if we pass the light through the glass of milk, we can observe the path of light from the milk of the glass. But if we pass the light through the sugar solution, we are not able to observe the path of the light in the sugar solution, because in the sugar solution the size of the particle is very, very small and they are not able to reflect the light from it. But the size of the particles in colloidal mixtures is little bigger than solution particles, so they reflect the light, and all the particles, when they reflect the light, the path of the light become visible from that kind of mixtures. So Tyndall effect is always visible in the colloidal solutions and suspension solutions, and this is very, very important in exam point of view. So here we have the normal life phenomenon where we observe the Tyndall effect. You can observe here. Now here we can go through again from the true solution, colloid solution and suspension. In these pictures you can observe the particle size of the true solution. For example, the solution of the sugar and water. In that kind of solution you can observe the size of the particles of both are very small. Sugar solution will dissolve, when sugar dissolve in water, the size of the particle is very small, and the size of the particle between 10 to the power minus 7 centimeter and 10 to the power minus 5 centimeter in colloidal solution, and the particle size is greater in suspension solutions. So we have to remember the size of the particles in these three kinds of mixtures, and we have to remember the colloidal particle size is intermediate between the suspension and true solutions, and colloidal solutions are effectively show the Tyndall effect. It means when we pass the light through the colloidal solution, the path of the light becomes visible in the colloidal solution, and this effect is known as Tyndall effect. This is all for the day, and next video we will discuss about the separation of the mixtures method, the methods of separation of the mixtures. Till then, bye.